Hello, this is question 14 on paper 2 Edexcel 2025. The height of the tide H meters in harbor is measured T hours after midnight, and the rate of change of H is modeled by this differential equation. So we have dH by dt is a just cost function that is oscillating. Yeah? A or B are constants, and T is measured in radians. Given that the largest value of this rate of change is 2 meters per hour, so they are talking still about the rate of change of, also about this function, and then they give us a couple more pieces of information, and they ask a complete value, a complete model. So we are going to use this to find any constants here. When they say the largest value of this rate of change is 2 meters, they are still talking about the rate of change without integrating, which means the maximum value of this function is 2. And because the maximum value of cos is 1, that means this A is going to be 2 straight away. Yeah, so we can say without much explanation, this is going to be a B mark, that A is 2. Yeah, just because the maximum value is 1 of dH by dt. So remember, it's not the maximum height, is dH by dt maximum is going to be 2. That means A is 2. Now, the time between consecutive tides of maximum height in the harbor is 12 hours. Now they are talking about maximum height, not the rate. Yeah, the same that happens here. And that means we are not talking about this function, we are talking about h. So we are integrating this function. When we integrate this function, we are going to get an sine function. I'm going to show you, we can start integrating already. So we have, to integrate the function, we have dh divided by 2. No, we are not dividing. So dh is going to be a, which is 2, cos bt dt. We are separating variables. We integrate both sides. So we will have something like h is 2 sine bt divided by b, just integrating that, and a constant of integration. Yeah, so my h is going to be a sine function. When they say the time between consecutive times maximum height, remember these functions, either the cos or the sine, it doesn't matter if you look at one or the other, they have they are periodic. Yeah, so the time between two maximum heights is going to be one period of the function. Yeah, the time between two maximums or two minimums is going to be one period. Period of sine or cos, remember, is 2 pi. So this is a normal period. When we multiply something, a trigonometric function, by a constant, we are doing a horizontal stretch. So our period now, instead of being 2 pi, is going to be 2 pi divided by 2 by b. So the period of the new function is 2 pi divided by b. So this function repeats more frequently. Yeah, the scale factor of the transformation is 1 over b. So this function, instead of, if I'm multiplying, for example, if b is 3, instead of having a whole wave, I'm going to have 3 waves here in this space. So new period is this one. And this, they say, is 12 because this is the distance between two maximums. Yeah, so this is 12 hours. From here, we can deduce very quickly that b is what? Pi over 6. So we have two of the constants, a and b, and we need to find c, so we have the complete model. And we are going to use the last piece of information. The maximum height is 30 over pi. So what we are going to do is the maximum height is 30 over pi is 2 times sine pi 6. Now we know that constant, divided by pi 6 plus c. Maximum is going to be when this is 1. So when this is 1, we have that 30 over pi is going to be 12 divided by pi. Yeah, 12 divided by pi plus c. So when this is 1, this is 12 divided by pi, and that means that c is 30 over pi minus 12 over pi, which is 18 over pi. So your full model is going to be, I'm going to make space, your full model is just going to be what we have, just writing the constants. Yeah, so we will have something like h is going to be 2 sine of pi over 6 t divided by b. b is pi over 6, so this becomes 12 plus 18 over pi. Yeah, so this is pi over 6. I just multiply the 6 by the 2, and this is 12. And this is the full model. That's what they're asking you. Yeah, that's all.